To put together the casing for this microphone preamplifier, then if you have bought the same plastic casing what I put in the video description, you can pretty much just follow the steps. So first just cut off this plastic thing which normally comes with the unit here, this plastic tape, so that you can open the case. Then first you're gonna work on the top portion. So what I did is that first of all I tried to figure out where I will gonna be putting the battery in, and I selected this particular plastic case because one 9-volt battery very nicely fits inside this case, right, like that, okay. And as you see, there is still plenty of space next to the battery to put in that small preamplifier board. Then to have the power switch installed, I have cut a small slit with an X-Acto knife right around 3 centimeters from the side of the plastic casing. And as you see, the hole is not exactly square, but hey, it's good enough for my application. I never claimed to be a professional, I'm just a donkey. Anyway, so then I also drilled small holes here. I found that drilling these holes is actually easier to do with an X-Acto knife. So you just take the X-Acto knife and you just drill into the material. It's a rather soft plastic, so it works fine, no problem at all. This way then I have just drilled 2 smaller holes where then I put through these 2 screws. So I was able to fasten the power switch. Okay, that's what you see right there. Then, as you know, we're gonna need 2 holes drilled on the case. In one of the holes, we're gonna need to have the audio input female jack installed. This is the one right here. So using the same technique with the X-Acto knife, I just drilled the hole which snugly fits this thing right here. Then we can use this metallic fixture there then to screw it in the plastic. Next to this larger hole for the audio input, I cut also a smaller hole. That's because through this smaller hole I'm gonna be installing one of these rubber grommets, and the cable which will be the output audio cable. And actually I have taken this shielded cable from an old Xbox gaming console. So I drilled the hole to snugly fit again this rubber grommet. Then let us look at the bottom of the case. Regarding this plastic bottom of the case, normally there are 4 of these plastic standoffs here molded into the plastic, okay. And since this is for a custom sized PCB, what we are using, we cannot really take advantage of these standoffs in order to fasten the board to screw it inside the case. I'd like to place the battery here where there are now these standoffs originally made by the manufacturer, which means that I needed to get rid of those standoffs. And what I did was that I just took the flat tool, just grab one of these, okay, these standoffs, squeeze it and then twist it off. And then the rest I was just scraping it off with a sharp knife. And this is how I ended up with nearly flat surface in those areas. So now this, where the battery sits right here, is sitting nice and flush, no problem anymore. But then, of course, we still needed some way to fasten the PCB inside the case. And this is why you see these two holes drilled right here. So I have measured. These holes are around 2.7 centimeters away from this plastic right here. So not the very side, but this thing here. And yeah, so that is where the two holes are drilled. And what I'm doing is that I'm actually using two of these plastic standoffs, which I then place in the next to the hole. And from the other side, I just screw the thing in. Okay, let me show that to you. Here are then the two plastic standoffs. They are just simply screwed in from the bottom of the plastic casing. The standoffs themselves are 8 mm tall, but you can use any standoff up to a centimeter, it's gonna work just fine. For the distance between the two standoffs, the holes where I drilled, I just used the distance on the board so that I can just place the board nicely right there on top of the two standoffs, okay? And I can just use screws to screw the board nicely in, to fasten it in two places into the case, and it's really not going anywhere. It's very rock solid in there once I screw it in with those two screws. For the power switch, I'm using about 8 centimeters of red wire, so I'm just gonna snip it off. Then I'm gonna clean the two ends of the wire and solder it to the middle pin of the slider switch. After the wire is being soldered to the middle of the slider switch, now it's time to put in the battery power connector. So I'm talking about this thing right here, okay? And I wanna have my unit set up such that when I push up the button like that, that is when it is turned on. So that means that I'm gonna have to then solder the red lead from the battery connector into this lead of the slider switch. So then here is the wire which will go to my PCB, and this is the wire which is then going to the battery lead. So practically the battery will be put here, then this will be the positive power lead going to my PCB, and the black lead coming directly from the battery connector is then the negative power lead going to my PCB. Next, then we're gonna prepare the audio output cable. Okay, so this is the cable which I already showed you. So then it means that this end with the mechanical retention will be inside the box, and I just cut roughly about 15 centimeters of the cable. So this is the other end where I already put up a bit of solder on the cable so I can actually solder it. First of all, then we need to insert this small rubber grommet which came with this Xbox headset into this plastic. Then through this grommet we're gonna push through this cable. Of course we're gonna leave a lot hanging because we are just at the testing stage of the board, but yeah, it's good to do parallel both the mechanical assembly and the electronical one because you can be done a lot faster this way. It is then time to put together the audio input and output jacks. So first I'm gonna put together the output jack, which then gonna be this 3.5 millimeter male stereo jack with this jack housing, what I've showed at the beginning. And as the cable, I'm gonna be using this shielded cable, which actually I took from an old Microsoft Xbox playing console. I have plenty of these headsets laying around because I was repairing the playing consoles. So anyway, if you cut down this end, which is then leading to the headset, then you will get a really nice rubberized cable where there is a bit of rubber already sealed, a kind of ring on one of the ends of the cable, and you also get one of these small rubber grommets. So this can be used, to get the mechanical load of this cable, so whenever you are yanking on the cable will not break. Okay, this is why I will use this grommet and this cable. And the white thin cable inside, if eventually you are using the same cable, the white thin cable is being shielded. The other two cables are not shielded because they are normally going to your earphones. So I just soldered those together. Okay, and then this will be the audio output signal, and then I will solder this to the jack. Let's go. So then here is the rubber grommet, then put really snug into that small hole, and now we're just gonna push this cable through such that this release end will be then inside this box. For the time being, it's a good idea to leave plenty of slack inside the inner portion of the box, because the board is not fully finished yet, plus you need a little bit of cable to be able to bend it around when you want to solder it into the PCB. Anyway, then let us also install now the audio input jack. Here is then the audio input jack in my third hand being fixed in. So as you see, the two shorter legs are the ones which are then the signal input. The longer lead here is the ground. So we should then solder a cable to this. And as I've showed, I'm gonna be using this audio cable, a rather short cable. Actually, this is even way too long for the real build. So, which I stole from an old CD player. And what I will then do is then solder the inner lead, which is the signal lead, through these two holes here, okay, the two signal pins, and the outer jacket, which is then the shielding, I will then solder it to this right here, to this ground plate of the connector. Here is the audio input jack then soldered. So as I mentioned, the black thicker lead is at this longer lead, which is practically this body here, the ground. Regarding the signal leads, please notice that I actually braided the two wires together, because remember, we are using a mono preamplifier, and that means that we have only a single signal coming in. And as you see, I just simply pushed the wire through these two signal leads right here, and I just soldered them down. So it means that they are now in parallel, So it doesn't matter in which one there will be the audio signal coming in. We will just amplify a simple audio signal, a mono signal. Because if you don't do this, then yeah, I mean, you often have this comment from YouTube like, my left ear really liked this video. I mean, we don't want that. And often you simply forgot to fix that in post-production. So that is what we are doing here in hardware, so to say. And we're gonna do, by the way, a similar thing to the audio output jack as well. It is then time to fix this audio input jack inside this plastic case. So as I mentioned, I will just simply screw it in and then screw this metal jacket thingy from the outside on. Since there are some exposed leads at the end of this jack, namely it doesn't come, you know, with a jacket, a plastic jacket, I just used a little bit of Kapton tape to insulate them, because I don't want to touch anything else, you know, with the audio input leads. And yeah, I mean, do this before you actually build it into the case. So here is then the input audio jack with the input audio cable. I mean, this cable is now really long. For the final version, I will cut it short, as short that I can just barely install the PCB. But for the testing stage, this is fine. And then this is here the output audio lead. As of yet, there is no output jack on it. This is what we're gonna put in next. Regarding the audio output jack, first of all, don't forget to slide in this plastic casing on the cable before you do any soldering. Otherwise, you know, you're not gonna have space to put on this plastic casing anymore. Next, then solder the connector on. Let me zoom in even more. So here at the audio output, notice also that we did the same dirty trick, that the two audio output pins are actually soldered together. So these are the two shorter ones. So these are leading to these two terminals here. The big one is the ground terminal. So this is the connector for the ground terminal, and this is just simply soldered to the shielding of the cable, and the inner shielded signal cable is then soldered to the two audio output leads. On the output audio jack, also notice that there are these small ears, okay, on this shielding metal strip right here. So the main idea behind is that we have to put in the cables inside, and then using such a flat tool, we just crush the whole thing together, so then it holds against mechanical stresses. So let me do that. Here is then the connector clamped down. By the way, when you are crushing these metal pieces together with the wire in the middle, I mean, best would be to actually do it when you still have the plastic casing on the top. I made the mistake of cutting the wires way too long. But in any case, do not go very crazy when you are, clamping this metal, because then you might just cut the wires inside. So it's, just be relatively gentle with the thing. And after this is done, you can just then slide this plastic boot on the connector, and of course, put it on there and screw it on, and it will look like a nice connector. After we are close to be done with the box, namely we have the input audio lead, the output audio lead, the power cables, and the power switch in, then it's time now to install the board or at least, put it in that we can do some first testing. Here is then the board. Here on the right hand side, on the negative pole, I already installed one of these turrets. I just simply soldered it into the board. And this is because, as I mentioned, at this point we're gonna need both the negative side, or the shielding, so to say, of the output audio cable, and also the negative battery. And here we're gonna then install the microphone input, namely here in the upper side. So as you see, there are two holes. In the upper one, I'm gonna install the input lead, so the inner lead. And then in the lower one, I'm gonna install this here, which is then the shielding of the input audio. So practically this is then the shielding of the microphone cable. On the microphone input side, please notice that I also braided the two wires together, because we are using a mono amplifier board. So yeah, I just braided it together, and we then just gonna solder it into the microphone input. Here is then the microphone input being soldered in. So as I mentioned, the two signal wires are braided together, and they are soldered close to the capacitor side, because this is the signal side. And then the other one is then the ground. So this is further away from the capacitor, and this is then going to the shielding of the audio input cable. Then next, let us then solder the power and the audio output leads as well. For soldering these leads here, actually I found that I had to remove this small turret, which was normally on the negative pole of this connector, because it just made life even more difficult to solder things together. So what I will do is then just simply solder the shielding of the audio output, and first I will just braid it together with the negative wire of the battery. Here then we have these wires braided together. So now, since these holes are quite large on the PCB, I can just simply push this braided wire combination into the negative pole, solder it in. Here is then the negative pole of the battery wire and the shielding of the audio output cable then being soldered into this negative rail. And next I'm gonna then solder the audio output lead, so this thinner white wire right here, which is running inside this shielding, this one here, to the middle connector, which is here marked as NF. Now solder in the positive wire coming from the battery power switch right there into the positive terminal on the PCB. After you have soldered in also the positive lead, so this red wire, then technically speaking, you are pretty much done with the wiring and with the soldering. So it is about time to actually do the first test on this PCB. For that, make sure that your power button is on the off position. Mine is on position up here, so it is off right there. Then it's about time to actually put in the battery. So the battery just simply snaps in. So it's obvious that the smaller, thinner pole goes to this bigger thing on the battery connector, and of course this smaller one to the bigger one on the battery. Yeah. So after you have put the battery on, nothing should smoke, hopefully, because the switch is actually switched off. To actually test your microphone preamplifier, take care that the PCB is not being short-circuited by anything. Also that the wiring everywhere is fine. Okay. Then next, plug in your microphone into the audio input jack right here. And plug in your audio output jack to your camera's microphone input. Okay. I mean, if you are using this cable which is making the whole cable longer, it's definitely easier to do that. Or otherwise you have to make this microphone output cable or the preamplifier output, I'm sorry, a lot longer. And when everything is done, then you just flip on the switch and hope that you're gonna get some amplification. Here is then the microphone preamplifier in action. I must say that so far I'm loving the result. Namely, the background noise have dropped tremendously, I mean it. So normally, you know, you have always this hissing sound like there would be rainy, windy, whatever in the background that is completely gone. What you hear now, of course, is a car driving past by. It's summertime, so I need to keep the window open. I mean, seriously, the background noise drops so much that normally I cannot reach this level of quietness even after go 2 stages of post-processing. So yeah, for me it was totally worth to build this preamplifier. And also one negative point about this preamplifier, by the way, is that now, since there is a high gain here at the microphone and I completely switched off the gain control of the camera, now you need to be careful and you need to speak, you know, using the same level of how loud you speak. Otherwise it's really easy to peak the microphone and to overdrive the preamplifier in the camera. So then you actually get distortions and pops. So yeah, you just get more used to how to speak, because I still have the tendency to often just scream into the microphone like a donkey. So yeah, I definitely need to get rid of that. In my honest opinion, this is a total win, because for about 20 some euros we got a really good preamplifier, and we can then totally cut off the background noise, so it's actually easier to understand what you are speaking, which is particularly important for tutorial videos. Regarding then the more or less final build, as you can notice here, I have actually changed R3, and instead of 180 kilo ohms, I have put in only 100 kilo ohms. And this is because I found that if I used the 180 kilo ohm, original resistor, then the gain of about 150 was way too much. Even after I turned off completely in the camera the audio gain, I set down to 0 decibel. I also set the microphone boost to 0 decibel as well. It was still overdriving the camera, so you had really sudden, distortions and pops. This is why I reduced it to 100K. Then the P1 potentiometer is then set to the lowest amplification. So at the end of the day, then I get a gain of roughly about 70 to 80, and the audio output level potentiometer here is then set roughly at the middle of the scale. And yeah, I think for me this gives the best audio, at least with my microphone, what I'm using, this lapel type microphone, what I just showed you. So of course this means that depending on the microphone your mileage will vary, so you might have to choose a different resistor here based on your microphone. After testing this thing and at least personally being happy with the result, then it's time to actually now install the board and the battery inside this case. Of course, using this bottom plate which I already showed you. So I will just screw the board to these two standoffs. This is then how the board looks after I have screwed on the two screws in this bottom plate. I don't really want to move the board around because it's actually active right now. I'm using it. So in the next stage then I'm gonna put in the battery, as I already showed you, inside this plastic casing, and then put the board and this bottom thing on inside, and then using the 4 screws which normally came with the plastic casing, then I'm gonna fix this bottom plate, and then the build is done. You can just put this thing in your pocket, push in your microphone here, push in the lead, this longer cable for your camera, plug it into your camera, and you're good to go. Here is then the battery installed inside this plastic casing with this battery lead on. You just push it nicely in right next to here to the left side, and it is a really nice snug fit there. I mean, this plastic case is just like it would have been made by the manufacturer for a 9-volt battery. It's awesome. Then in the next stage, then we're just gonna put the board inside the plastic casing, push it down and screw it down. This is then how the final product or preamplifier looks when it is put together. So it is a nice and compact design. There are only 2 of these wires coming out. There is 1 power switch, and then the rest is all housed inside this plastic box. The microphone preamplifier is then having this small gray output for the output cable, and that is then being connected to this long, nearly 2-meter shielded audio cable which I showed you at the very beginning. So it means that the actual camera can be easily further away from me. It doesn't have to be very close, and I'm still not picking up much noise because the preamplification is done close to the microphone and not far away inside the camera. And this way I can just put this preamplifier in my pocket, then attach the microphone to my lapel on my t-shirt, and then plug in the output lead, which is this gray one in this case, into my Canon camera, and I can start the recording with a lot lower background noise. After then you have screwed in the 4 screws which came inside this plastic box with the plastic housing. So yeah, I mean, then we have the final product. I mean, I kind of like it. At least with the audio quality I'm happy. The only thing which one could improve is to cut down these plastic things here. Just cut it off or sand it down, and then it uses less space, so it fits even more nicely in your pocket. And then, yeah, I mean, I hope that now with this preamplifier I can actually do some how-to videos where you can hear what I'm talking about without this huge noise in the background. Many thanks for watching, and yeah, then hopefully see you in the future in some of my how-to videos.